The new section is entitled Solving Linear Equations, of course, linear differential equations. You have a function of x times dy dx plus some function of x times y is equal to some function of x. The first thing you want to do is you want to have the multiple of dy dx to be 1. That is, we want to divide by a of x. To divide all terms by a of x. This fraction is just dy dx plus, just say plus. So you're going to have some function of x, d of x over a of x is some function of x. I'll call that p of x times the y. And this fraction is some function of x, c of x on top, a of x on the bottom. C of x might be 2x cubed plus 4x minus 11, and a of x can be pi times x to the e minus 4 ln of x plus 13. And when you divide these two, you get a function of x. I'll call that g of x. So this is the standard form of a linear differential equations. Now, how can we solve such an equation? First, let's put it on another page. If you have dy dx plus a function of x times y equal to yet another function of x. If you were to multiply both sides by e to the integral of p of x dx, magic is going to occur. And multiply that by what I just said, e to the integral of p of x dx, dy dx, plus, now I'm going to multiply that by our magic function, p of x times y, and I'm going to take g of x and we'll multiply it by our magic function. A magic function happens to be called an integrating factor. But that's just the word name. I'm not big on names. It's concepts that matter. Now, the magic is happening right here. Because that left side is a derivative of some function. It's the derivative of y times e to the p of x dx. I meant to say e to the integral of p of x dx. And to convince you of that, it's a product rule. The derivative of the first is dy dx times the second function. Well, that's exactly this. It's exactly that. Ran the room, so I'll put the plus here. Plus, I leave y alone and multiply by this derivative. Well, the derivative of e to any function is e to that function. Function happens to be an integral, I don't care, times the derivative of that exponent, which is just p of x. The derivative of the integral of p of x dx is just p of x. Well, y is y, p of x is p of x, this e function. Oh, that's the second term. That is, the left-hand side really is a derivative. Let me write it down neatly again. So we're going to derive the formula, and then we'll always use that formula. The derivative of this is equal to the right side, which is this. I'm just going to write g of x first. I didn't take any derivative yet. All I said was this happens to be that, the derivative of some function. And the right side I didn't change. Now I'm going to integrate both sides. If I integrate the left side with respect to x, I just get this back. Because the integral of a derivative is just the derivative you take in it. It's just this function. Leave, if you take the derivative of this function and then you undo it, you get back that function. I took the integral of the left hand side, and now I'm going to take the integral of the right hand side. This is the right hand side, and I'm going to take the integral of it with respect to x. Now our goal is to find, this is the original differential equation, or it's the equation in standard form, and you want to solve for y. Oh, you want to solve for y? Divide by this. So the right side so far is not changing. And now I'm going to divide by e, the integral of p of x dx. This here is the formula. If you have dy dx plus a function of x times y equal to a pure function of x, that means that y is equal to the integral of g of x e to the integral of p of x dx all over the integral of p of x dx. Now, how I remember this is in top and the bottom, and also in the top is g of x, and that's it. Now, if it turns out, we're going to derive one other formula, and then we'll use these derivations to solve linear differential equations. If you understood everything I've done so far, great. If you just want to memorize this formula, fine, you'll always get it right. If g of x is 0, this is called the homogeneous equation. Homogeneous differential equation, because it equals 0. The pure function of x is just 0. So y is equal to the integral of g of x, which is 0, times some other stuff, which is well defined, zero times e to that integral is 0. The integral of 0 times dx is 0. But that's not true. The integral of 0 dx is some constant. What do you take the derivative of to get 0? Answer, a constant. And on the bottom, we still have that integral. Now all I'm going to do is bring it to the top. And when you bring something from the bottom to the top, you change the sign of the exponent. It's going to be negative. If dy dx plus p of xy equals 0, then that's what y equals. Y is equal to this. But that's going to come out if you just memorize the top formula. Now, one last thing I want to show you is that if y, I call it y sub p, if y's particular is a solution to dy dx plus p of x times y equal to g of x. That is, dy sub p dx plus p of x times y sub p is equal to g of x. That is, if you replace y with y sub p, the equation is valid. The left side and the right hand side are equal. Now, if y sub h is a solution to the homogeneous equation, that is, that should be y, that is g of x is 0. Then yp plus yh is also a solution to this linear equation. And the reason is, you take the derivative with respect to x of yp plus yh plus p of x times y, which is yp plus yh. Well, the derivatives distribute. So you get the derivative of y sub p plus, I'll distribute first over there, p of x times y, I'll bracket that, plus the derivative of yh, dyh over dx, plus p of x times yh. Now, that first bracket to the left, that's g of x. That's what we said earlier. That is g of x. And what's in the blue bracket on the bottom, which happens to be this, equals 0. And g of x plus 0 is g of x. You can always add, if you have a particular solution, you can always add the homogeneous solution. Now, remember that this here is the solution to linear equations. G of x e to the integral of p of x dx all over e to the integral of p of x dx. That is the solution. Memorize that. It's going to keep coming up every time. Okay, so now let's do lots of problems. We have the formula in front of us, and we're going to do lots of problems. Suppose you were asked to solve this differential equation. So the first thing is, you have to have dy dx alone, that is being multiplied by 1. That is, so now since it's multiplied by x, we'll divide by x. We'll divide by x. And this gives me dy dx minus 4 over x times y equals x to the 5th e to the x. Remember, I want it to look like dy dx plus some function times y. That's why I isolated the y equals g of x. So p of x, including a negative sign, is negative 4 over y. And g of x is that function. Okay, so that was a big step. Now we go right to our formula. Y is equal to the integral of g of x, e to the x, times the integral, times e to the integral of p of x, which is negative 4 over x dx. Negative 4 over x dx over the integral of e to the integral of negative 4 over x dx. Well, let us do that integral on the side. The integral of negative 4 over x dx. I can factor out the negative 4, and I just get dx over x. Well, I know that integral is ln of x. And the 4 can come up as the power. Now, e to that. E to ln of anything is just the anything. Now, I do have a little mistake here. So, let us have no mistakes. Like every integral, you have a constant plus a constant. This can come up, so we have ln of x to the negative 4. Plus, instead of c, I'll say ln of c. ln of c is just another constant. But now if you have ln of one thing plus ln of another thing, this becomes ln of the product. So just copying, I have the integral of x to the 5th e to the x times e to that integral, which I just solved. It's ln of cx to the negative 4. But that's dx. And we have the same exact integral, including the same base on the bottom. We're going to get the exact same constant, cx to the negative 4. We're going to get the same constant c. You integrate the same functions, we're going to get the same constant. Okay, now another rule. E to the ln of anything, as long as this is not negative, is to anything. So the record ln of e to the anything is also the anything. So now, in our case, we have e to the ln of that. What I just circled twice now, that's the anything. You have to know that rule, especially for these type of problems. You get x to the 5th, e to the x, e times e to the ln of that. Well, it's just that, dx. And the bottom is just that. Now, this constant can come out in front, and it's the same as that one. So that kind of cancels. So now, I'll multiply this by this, I'll get x times e to the x times dx, all over x to the negative 4. That is what y equals, but it still has an integral. Y is equal to the integral of x e to the x dx to x to the negative 4. Just confirm I copied that right? Yes. Now, this is a classic problem where you would do the spaghetti method. To solve this integral, you would use the spaghetti method. I'll take the derivatives of x. First I write down x, I take the derivative of that, which is 1, I take the derivative of 1, and I got to 0. And I want to get to 0. Now the other function, I have to integrate it. First, just like I wrote down x, I write down e to the x. Now I integrate e to the x, and I get what I get, which happens to be e to the x. And I integrate again. So now I'm ready to write down my answer. It's this product minus this product. It's x e to the x minus 1 e to the x plus a constant. Factoring out the e to the x times x minus 1 plus a constant. E to the x times x minus 1 plus a constant. Okay, you can leave the answer like that, or instead of having x to the negative 4 on the bottom, you can have x to the 4 on the top. You have e to the x times x to the 5th minus x to the 4th plus cx to the 4th. So there's your answer. There is your answer. And we can verify this. I claim that y distributing that e to the x is x to the 5th e to the x minus x to the 4th e to the x plus c times x to the 4th. I claim that that's what y equals. Now, the original equation said that x times dy dx minus 4 times y must be x to the 5th e to the x. So let us work on the left side. Let us find y prime, or dy dx, multiply it by x. And maybe it would actually be easier to do this in the factor pair, like I have at the top right. The derivative, so it's a product here. The derivative first times the second, plus just the first, which is e to the x, times the derivative of the second function, 5x to the 4th minus 4x cubed, plus the derivative of that, which is 4cx cubed. As the formula says, I want to multiply dy dx by x. The x times y prime will be e to the x times x to the 6th minus x to the 5th plus e to the x times 5x to the 5th minus 4x to the 4th plus 4cx to the 4th. Now I take away 4 times y. I take away 4 of those. So why don't we clean this up a little bit? I just have 1x to the 6th, so I have e to the x to the 6th. Now I'm taking away x to the 5th e to the x, and I'm adding back 5. So I have 4 e to the x to the 5th. So I dealt with this and that and that. And now I am taking away, because of that minus sign, 4 e to the x to the 4th, and I'm adding on that 4cx to the 4th. That is xy prime. Now 4 times y, I just have a 4 here. It's this, I'll distribute. I get 4 e to the x to the 5th minus 4 e to the x times x to the 4th plus 4 of those, plus 4 times cx to the 4th. Now I subtract these two rows, and let us see what we get. Oh, 4e to the x to the fifth minus 4e to the x to the fifth cancels. Negative 4e to the x to the fourth. Negative 4e to the x to the fourth. Exactly the same. And I am subtracting. So they cancel. Positive 4c x to the fourth. Positive 4c x to the fourth. I'm subtracting. They cancel. The only term that survived was e to the x to the sixth. Exactly what we were supposed to get. Fine. I wrote it backwards. The multiplication does commute. Like always, let's just do many of these problems. Let's try this homogeneous equation. dy dx plus 2y is 0. Now, remember, this here is the formula. It's integral of g of x times e to the integral of p of x dx. So now if g is 0, the whole top is just 1, or a constant. The whole top is a constant. Because the integral of 0 dx is a constant. In the bottom, we have this. So if the top happens to be just a constant, and I bring this up to the top, I get that. Or you can work out this whole formula, and everything's going to follow nicely. The top will just be a constant. That's g of x, and whatever y is multiplied by p of x. So y is equal to c e to the negative integral of p of x dx. Well, let's find out what this integral is. Let us find out what negative integral of p of x dx is. So there's the negative, there's the integral. P of x is positive 2 dx. So that negative, this integral is just 2x plus a constant. And the base of this is e. This is the same as e to the negative 2x times e to the c. Because when you add those two exponents, which you are supposed to do when the bases are the same and you are multiplying, you'll get that power. But e to the c is just some number. Let us call it c times e to the negative 2x. That is what y equals. Problem is done. We know the formula. We know the formula. We know the formula. These are not that bad of problems. 4 dy dx minus 12y equals 8. We need to get it into standard form, meaning no multiple in front of the dy dx. That is, I'm going to divide by 4. I'm going to divide by 4. So I get dy dx is dy dx minus 12 over 4 is 3, y equals 2. That's my p of x, and the 2 is my g of x. Okay, I know the formula. I know that y is equal to the integral of g of x times e is the integral of p of x dx over the e is the integral of p dx. So let us solve this integral. The integral of negative 3 dx is negative 3x plus a constant. So it's e to the negative 3x times e to the c. This is just c times that. Now, I'm not suggesting those c's are equal. I can even tell you what this c equals. Or I can tell you what that c equals. It's ln of c. E to the ln of c is c. So e to the c is some constant, and it's being multiplied by e to the negative 3x. So we have the integral 2 times this piece, which is c e to the negative 3x times dx, all over this integral, or that denominator, which we just worked out to be this. Now those c's are exactly the same. So what we have right now is an integral of 2 e to the negative 3x dx. We need to divide this by e to the negative 3x. And this 2 can come out in front. That is a rule that calc students should know. The integral of e to the kx dx, where k is some constant, is e to the kx. But you have to divide by k. Our k is negative 3. So we have 2 times that integral, which is in this form. So I get back e to the kx, and then I divide by k. But that's just in the bottom, plus c. And that's still in the bottom. So now I have 2 divisions. That division gives me negative 2/3. The e to the negative 3x cancels. Plus c, and we have c over negative 3 e to the negative 3x. That's some constant over e to the negative 3x. You can rewrite this as negative 2/3 plus c e to the 3x. I brought e to the negative 3x to the numerator, and I changed the sign of the power. And that is what y equals. That is what y equals. Let's try some more. Suppose that you were given this equation, dy dx plus 4xy is x. So that's p of x, and that pure function of x, well, that's g of x. Okay, we know that y is equal to the integral of g of x times e to the integral of p of x dx divided by e to the integral of p of x, which is 4x dx. So let us put our energy into simplifying this. The integral of 4x dx is 2x squared. I added 1. That power is understood to be 1. I added 1, got 2, and I divided by 2. And the 2 in the bottom goes into the 4 2 times. Plus a constant. Plus a constant. But that constant I can just pull out in front here. So this is e to the 2x squared times e to the c. And just to make it real clear, I can say that the multiplication commutes, and that's just the constant. So I get that. C e to the 2x squared. Okay, so y is equal to an integral sign x, and then this piece, which I worked out on the bottom, is c e to the 2x squared dx all over this, which I worked out. There it is. I claim it's that. C e to the 2x squared. Now you cannot say, I haven't said this yet, but you cannot do that. That you can't do. But you can do it with the constants. Because this c here can really come out in front of the integral sign. And then they cancel. The one on the top and the bottom cancel. So let's write down what we have. X e to the 2x squared dx over e to the 2x squared. Now, if I were to call this u, then this piece would be e to the u. It'd be the integral of e to the u. But if u is 2x squared, then du is 4x dx. Du will be 4x dx. Well, I have the x and I have the dx. I just need a 4. Well, you can put in the 4 on the top as long as you also divide by 4. So, this piece is e to the u. 4x times dx, that's du. It says so right here. And in the bottom is 4e to the 2x squared. And now we're getting places. That integral I know. I know that integral. That integral on the top is just e to the u plus a constant over 4e to the 2x squared. But u, as it clearly says, no random guessing, is 2x squared plus c over 4e to the 2x squared. And now I'm ready to write down the answer. This fraction is just 1/4 plus c over 4e to the 2x squared. Now, if you like, you can say that c over 4 is just another constant. So here is one answer, or one way of writing the answer. Let's try another one. We learn by examples. X plus 2 squared dy dx is 5 minus 8y minus 4xy. So remember, next to the dy dx, I want to get some multiple of y. I'm going to bring both of these over. And now I'll have x plus 2 squared dy dx. Now I'm rigging that a y can factor out. So I'll have the minus 8 goes over as plus 8. The minus 4x goes over as positive 4x times y. Okay, of course you know the y is going to factor out if you're going to do this move. And one mistake, if you bring it over, it becomes plus, not equal. You're bringing it over because you know the y factors out. We'll factor it out. And it's going to equal to that lone 5. Now one more step. I can pull a 4 out from here. 4 times 2 is 8, plus 4, the 4 in front, times the x, gives me 4x. Y equals 5. Now, I'm almost in standard form. I'll divide by x plus 2 squared, each and every term. By design, that cancels, and all I'm left with is dy dx. Now please remember that 2 plus x is absolutely the same as x plus 2. and I can kill off 1x plus 2 in the top and 1 in the bottom. Since there are 2 in the bottom, and I just killed off 1, there's only 1 left. So I have plus 4 over x plus 2 times y. That y. I factored out the y over x plus 2 squared. So this is good. This is good because now I know that's p of x, and I know that that's g of x. Knowing that, I'm in business. P is 4 over x plus 2. P of x is 4 over x plus 2. And g of x, I think it had x plus 2 squared in the bottom, and it has a 5 on the top. So now I can write down the formula, the solution. Y is equal to the integral of g of x times e is the integral of p of x dx dx all over e is the integral of p of x. That's how I write p of x. That's how I write p of x dx. So what is e is the integral of 4 over x plus 2 dx? Well, temporarily you can factor out that 4, so you get dx over x plus 2. Now, if I were to call x plus 2u, then it turns out that dx is du, and the integral of du over u is ln of u. So like I said, u was x plus 2. So what we get is e to the 4 times that integral. But that integral is this. Plus a constant. Now this 4 can come up as the power. And I can even call this c ln of c. So what I have is e, and when you have ln of one thing plus ln of another thing, you just get ln of the product of those two things. And e to the ln of anything is the anything. Okay, so I write this up here. It's the integral of 5 over x plus 2 squared, that's this, times this, which we just worked out. It's c times x plus 2 to the 4th times dx. In the bottom, well, we just worked it out. It's c times x plus 2 to the 4th. Constants, unlike variables, can come out in front, and then they cancel out. Alright, so now we have to do a fairly simple integral. First, I'll say that 5 I'm going to pull in front. So now I have this over x plus 2 squared. Since the bases are the same, x plus 2, and I'm dividing, subtract the powers. 4 take away 2 is 2 dx. And the bottom is x plus 2 to the 4th. So here's the 5. Here's the x plus 2 to the 4th. This is on the top, in the numerator. What's the integral? Well, if I call that u, then that's du. This is just u squared, the integral of u squared dx, which is u cubed over 3, plus a constant. Same old game. I do this division first. I get 5 over 3 There's one more x plus 2 in the bottom than there is in the top. So 1 stays in the bottom. Plus c over this. Well, c over 3 is just another constant. So I won't write the 3. And this is what y equals. Try a few more. Suppose you were told that y dx dy minus x is 2y squared, and I'll make it an initial value problem. Now, this one is a little different because in the past we had dy dx. Here we have dx dy. So just remember, you want normally, or up to now, we wanted to get this. The x and y's were switched. If I switch the x and the y's here, I get dx over dy plus p of x, or x becomes y, times y, or y becomes x, equals g of x, well, x now becomes y. So that's the form that I want. And y of 1 is 5. That is, that's x, when that's y. Now just remember, x's and y's have been switched. Normally y is equal to the integral of g of x times e to the integral of p of x dx all over dx, all over the integral of, e to the integral of p of x dx. So in our case, just change those letters from x's to y's, from y's to x's. So instead of y, I write x is equal to the integral of g of y e to the integral of p of x dx all over e to the integral of, now normally it's p of x, so I should have p of y over here, sorry. And here I have dx, so I should be putting dy. I could have sworn I said the last one. P of y dy, dy. E to the integral of p of y, because x becomes y, times dx, which becomes dy. It's just alphabet soup. Okay. Now, like I said, I want to get our problem in this form. I want to get it into that form. So the first thing I'm going to do is I'm going to divide by y. I divide y dx dy by y, I just get dx dy. And now, when I divide the x by y, I get 1 over yx. And when I divide the 2y squared by y, I just get 2y. So, that's my p of y, and this is my g of y. So, I'm going to get the integral of g of y, normal. Okay, so I should be looking here. So, x is going to equal to the integral of g of y, 2y, times the n times e to the integral of p of y, which is negative 1 over y dy, over the e to the integral of negative 1 over y dy. So like always in these problems, we want to find out what the integrating factor is. What is e to the p of x dx? We have e to the integral of negative 1 over y dy. If I pull out that minus sign, now I know what that integral is. This integral is ln of y. Now minus is understood to be minus 1. I can put it up as the power. And e to the ln of anything is the anything. So that's just y to the negative 1. Or c times y to the negative 1. Because why? Because I rarely get a plus c here, a plus c, and I can call that plus c ln of c. So the numerator, the power is ln of y to the negative 1 plus ln of c. Ln of one thing plus ln of another thing is ln of the product of the things. So I can put the c there. Okay, cool. So I erase this, and I put c y to the negative 1. And then I erase all of this, and I put the same c y to the negative 1. And everything from here on is going to work out very nicely. Y times y to, first of all, the c's cancel. Y times y to the negative 1, well, that's y to the 0, which is 1. That is, I just get 2. This product, 2y times y to the negative 1, is just 2. dy, that dy, over good old y to the negative 1. Now the integral of 2 dy is 2y plus c over y to the negative 1. So y to the negative, dividing 2y by plus c by y to the negative 1, the same as multiplying by y. So you get 2y squared plus cy. And that is, oops, over here, that's what x equals. X of y equals that. We still have one last thing to do. We know that x is 2y squared plus cy. But when x is 1, y is 5. Okay, x is 1 is 2 times 5 squared plus c times 5. 5 squared is 25 times 2 is 50. 50 plus some unknown value is 1. That must be negative 49. 50 plus negative 49 gives you 1. So 5c is negative 49, which implies c is negative 49 over 5. So if I come here, instead of plus c, I'm allowed to put negative 49 over 5. So that is the exact answer. No constant. That's the exact answer. Let us try one more problem. Suppose you come to learn, or you're given that y prime plus tangent of y, tangent of x, excuse me, times y is a pure constant of x, a pure function of x, cosine squared x. So what we now know is that positive tan x, that's our p of x, and that there is our function of x, that's our g of x. So y is equal to a fraction, the integral of g of x times e to the integral of tan x dx over e to the integral of tan x dx. Well, the hardest part, or the big part, is to solve that e to the integral tan x dx. You need to remember that tangent x is sine x over cosine x. Now, if I let u be cosine x, which I'm hinting that the bottom I'm going to call u, well then du is negative sine x dx. If I put in a minus and I take out a minus, I'm okay. That minus is right here. Negative sine x dx, this, oh, that's du. Ooh, I know that integral. The integral, so there's the e to the minus, the integral of du over u is ln of u. Now, that minus you can think of as a negative 1, which you're allowed to put up there. So now you have e to the ln of something. Well, that equals the something. And u was cosine x. So you have 1 over u. 1 over cosine x. That is what this equals. Okay? So, a little typo, nothing big. Instead of g of x, I meant to say what it equals. And it equals the cosine squared x. So we have cosine squared x times this piece, which is 1 over cosine x times that piece, over this piece, which we worked out, and we concluded that it's 1 over cosine x. Okay. Now, dividing by that fraction is the same as multiplying by the reciprocal. So we have cosine x times the integral. Now when you multiply those two, you just get cosine x. So it's cosine x times this integral. The integral of cosine x is sine x plus a constant. And that is what y equals. But let's make this problem a little bit more interesting. Give it initial value condition. Suppose you come to know that y is 0 is 1. That is, when x is 0, y is 1. Okay, y is 1 and x is 0. So copying this down, except I put 0 for x. So 1 is equal to, the cosine of 0 is 1, the sine of 0 is 0, plus c. So what's inside that parenthesis is just c. 0 plus c is c. Now you just have to know your 1 times table. We're not even that well into the 1 times table. 1 times y gives you 1. The answer is 1. So c is 1. So we update this and we say that y is equal to cosine x times sine x plus 1. C is 1. And there's your answer. This completes the section on solving linear differential equations. Do lots of problems. They're simple.